Hi everyone and welcome to the next video in Java Collections series. After discussing list implementations before we move to other collection data structures, it will be a good idea to have an overview of synchronized versions of list. This video is about CopyOnWriteArrayList, but we will shortly review other synchronization options for the list as well. When it comes to working with multi-threaded environment in Java, we have different possibilities. One implementation which supports thread safety is vector. We can imagine vector as a version of the array list, but the difference is that it is thread safe, unlike the array list. We can define thread safety as a feature that allows the vector to be safely accessed by more than one application threads. Safely means without causing data corruption and leaving the object in an inconsistent state. This synchronization is achieved by using locks, so that one thread acquires a lock on the object and excludes another thread from modifying its state at the same time. Well, downside of the vector is performance cost, because each synchronized method call causes the lock acquisition, which slows down the performance. While there is a method being invoked, no other threads can perform the same operation until the current thread is done. Another way to achieve the synchronization for the list is collections.synchronizedList method, which behaves as a wrapper. While it can be seen as a comfortable feature to quickly wrap some list and make it synchronized, this way of synchronization has certain disadvantages, such as performance overhead due to synchronization of every operation and the flows when it comes to iteration. It might not be completely synchronized in every situation, and it might require additional effort to be completely thread safe. And another way of synchronization for the lists is CopyOnWriteArrayList, about which we are going to discuss a bit extensively in this video. CopyOnWriteArrayList is a thread safe version of the array list, and when we try to modify it, what happens is that it creates a new fresh copy of the underlying array, and the original one stays unaffected. This implementation is efficient for read-intensive operations, but definitely not efficient for frequent modifications, because it will be generating the new copies of the arrays every time. Now let's make a comparison between CopyOnWriteArrayList and vector. So vector is a legacy implementation introduced in Java since the beginning, while CopyOnWriteArrayList is relatively new, introduced in Java 5 version 1.5. CopyOnWriteArrayList is not blocking when read operations happen, as it is reading from the immutable array, while vector is acquiring the lock on each operation. In terms of memory overhead, CopyOnWriteArrayList might be a bit heavy when performing write operations. While vector does not create a new copy of the array, it only gets resized if the capacity becomes full. Modifications during the iteration for CopyOnWriteArrayList are safe and do not throw exceptions, because iterators are not fail-fast. What this means is that the iterator only works on a snapshot of the list, which was initially created, and new copies are not visible for this iterator. Vector has fail-fast iterator, and it throws concurrent modification exception if the list is modified while iterating over it. Now let's demonstrate CopyOnWriteArrayList, and let's create an example. So initially let's create main method, and inside main method let's create CopyOnWriteArrayList of type integers for this example, and let's call it CopyOnWriteArrayList equals new CopyOnWriteArrayList, and inside parentheses let's initiate integers. So let it be 1, 2, 3, 4, 5. Yeah, something like this. And now let's see the iterator behavior, which we mentioned before. So let's create iterator of type integer. Let it simply call, let it be called iterator equals CopyOnWriteArrayList, and declare iterator on this list. Let's do something like this. Let's make an add operation here. Let's add any number, for example, number 6. And on the next line, let's make a list of integers. Integer result new linked list, for example. Hit Alt plus Enter to import list, and in this results let's do something like this. So iterator for each remaining, and inside here we need to add function, so it will be result add operation. So it will perform add operation for each remaining element inside the list. And if we print after this, if we make this statement system out println result and print and observe what will be the outcome, we can see that outcome of this result is 1, 2, 3, 4, 5, but not 6, not the element which we added on this line. So what happens is that when we call this operation on iterator gets created with the initial values of the CopyOnWriteArrayList. So when we call add operation on this CopyOnWriteArrayList and add number 6, it does not modify original list for which the iterator was created. And this is why iterator can be safe in this case, so that it will not be inconsistent and it will not throw concurrent modification exception for the case of CopyOnWriteArrayList. Now let's summarize all the information provided in this video. So we reviewed several alternatives for achieving thread safety in Java, and we compared their advantages and disadvantages. We also had a little example when we demonstrated CopyOnWriteArrayList and how it behaves in relation to iterator. In general, there is no single silver bullet solution which would fit all the use cases, and the decision which implementation to use depends on the analysis of concrete situation and on the benefits and costs. If you find the content of this channel helpful, please give us like and subscribe, and I am going to see you in the next one.